Welcome to Orbit Observer. Settle in. Wherever you are right now, whatever kind of day is finally letting go of you, let it. Let your shoulders come down from wherever they've been hiding. There's nothing left for you to solve tonight, nothing left to carry, and no part of this that you have to stay awake for. If you drift off before I finish, that's not a failure. That's the whole idea. I'll keep talking softly either way, and the story will still be here, unhurried, whether your eyes are open or closed. I want to take you somewhere very far away tonight, farther than the moon you can see from your window, farther than Mars, farther than the great striped weather of Jupiter, farther than the pale rings of Saturn. I want to take you almost to the edge of where the sun still counts for anything, out to a cold blue-green planet lying on its side in the dark, and to one small moon that circles it. A moon that is, of all the large moons out there, one of the darkest things we have ever managed to photograph. And on that dark, dark world, I want to show you a single soft ring of light. Picture it slowly, because we have all night. Imagine a world the color of coal. Not black exactly, not the deep, pure black of the space around it, but a dark, even, dusty grey, like a lump of charcoal that has been sitting cold in an old hearth for a very long time. A whole globe of that colour, about 1,169 kilometres across, which is to say a ball roughly a third the width of our own moon, hanging in the perpetual twilight far from the sun. Almost nothing about its face changes as your eye travels across it. No bright continents, no swirling clouds, no white polar caps flashing sunlight back at you. Just that quiet, uniform, ashy grey curving away into shadow. And then, near the bottom of that grey world, near its middle, near the line we would call its equator, there is one crater. One bowl punched into the surface long, long ago. And on the floor of that single crater, laid out in a soft loop, is a ring of pale material that catches the faint sunlight and glows. Not a blazing glow, not a beacon, nothing that would hurt your eyes. Just a ring of something brighter than everything around it, a pale halo resting quietly on the floor of a dark bowl, on a dark moon, in a dark corner of the solar system. The single most reflective thing on the entire world. One point of light in overwhelming darkness. The moon is called Umbriel, and the crater with the ring of light on its floor is called Wunda. I want you to hold that image, because that's the whole reason we're here tonight. Not 100 facts to keep track of. Not a list to remember in the morning. Just that one soft ring of light glowing on the floor of one crater, on the darkest large moon of the planet Uranus. That's the thing your mind can circle, gently. The way you might circle a single warm lamp in a dark house until you find your way to bed. One ring, one quiet light, and the strangest, most soothing part of the whole story is this. Nobody can fully explain it. Let me say that again, softly, because it's the heart of everything. Nobody knows for certain what that ring is made of. Nobody has seen it clearly since the one brief time we glimpsed it. And nobody can even say for sure why the moon it sits on is so unusually dark in the first place. 3 unknowns, stacked one on top of another, what the ring is, when we last saw it, why the whole world is so black. And every one of those questions is genuinely open. Not open in the sense of a mystery someone is hiding from you. Open in the honest sense that the scientists who study these worlds will tell you plainly, if you ask them, that they simply do not yet know. The debate is real, the answer isn't in yet. And I find that, at this hour, strangely comforting. Not everything has to be solved before you're allowed to rest. Before we go any deeper, before we start our slow descent into that one ring of light, I'd love to know where in the world you're listening from tonight. Somewhere a long way from Umbriel, I'm sure. Maybe a bedroom with the lamp already off. Maybe a city apartment with the traffic gone soft below. Maybe a quiet house out where you can actually still see the stars. If you feel like it, and only if it doesn't cost you any of the drowsiness you've worked so hard to build, leave a note somewhere in the comments and tell me your corner of the planet. I genuinely like knowing who's out here in the dark with me, all of us circling the same small warm sun while I tell you about a far colder one. And if you're new here, and if the sound of this suits you, you're welcome to stay. There's no rush. The little subscribe button will still be there in the morning, and so will I. Consider that the whole of the housekeeping for tonight. Now we can let all of it go and just drift. So, Umbriel, let's start with how far away it truly is, because the distance is part of what makes that one ring of light so precious. When you look up at our own moon, you're looking at something close enough that a radio signal crosses the gap in a little over a second. It feels near. It feels like a neighbour. Umbriel is nothing like that. It circles Uranus, the seventh planet. The pale blue-green world that lies so far out that sunlight takes hours to reach it, arriving thin and weak and cold. Out there, the sun is not the great warm face that rules our sky. Out there, the sun is just the brightest star among many, a hard, little point of light too far away to warm anything. Everything at that distance lives in a kind of permanent dusk. And within that dusk, Uranus keeps a family of moons, and Umbriel is one of the 5 large ones. It is the 3rd largest of those 5, and of all of them, it is the darkest. That word, darkest, is doing a lot of quiet work, so let me unpack it gently, the way you'd unfold a blanket. When astronomers say a world is dark, they mean it reflects very little of the light that lands on it. There's a number they use for this, a measure of reflectiveness, and you don't need to hold on to the exact figures, but I'll give them to you softly anyway because they tell the story so well. Umbriel reflects only around 1/4 of the light that hits its surface by one common measure and by another, stricter measure. The fraction of all the sunlight it receives, that it bounces back out into space in every direction, it reflects only about 1/10, about 1 part in 10. 9 parts of the sunlight that reaches it are simply swallowed, soaked into that ashy surface, and turned into a whisper of warmth, and only 1 part comes back out to be seen. Think about that for a moment, because it's a lovely, drowsy sort of number. Imagine a fresh field of snow, the kind that's almost blinding on a bright winter morning, throwing nearly all the daylight straight back into your eyes. That's the opposite of Umbriel. Now imagine a lump of old coal or a worn strip of dark asphalt at the end of a long summer, the kind that drinks in the heat and stays warm under your hand long after the sun goes down. That's much closer. Umbriel is a cold, dark world. And the thing that makes it stand out, even among the moons of Uranus, is that its own siblings are noticeably brighter. There's another large moon called Ariel, the brightest of the 5, and Ariel reflects roughly twice as much light as Umbriel does. Same planet, same family, same neighbourhood of the solar system, and yet one of these moons is roughly twice as reflective as the other. They grew up together, more or less, out of the same cold material around the same young planet, and somehow one of them turned out dark. Nobody is entirely sure why. There's the second unknown, quietly settling into place beside the first. Why is this one so dark? Hold it lightly. We'll come back to it. For now, just let it sit there, one more soft question in a night full of them. And against all that darkness, all that even, unbroken, coal-grey dimness, there is the ring. That's what makes it so uncanny and so perfect for a night like this. If Umbriel were a bright, busy, varied world, full of light patches and dark patches and streaks and splashes, then one more bright feature would be nothing special. It would blend into the crowd. But Umbriel is not busy. Umbriel is about as plain and uniform a face as you'll find on any large moon. It is quiet almost everywhere. And so this single ring, this one pale loop on the floor of Wunda crater, does not blend in at all. It stands alone. It is the exception that the eye goes straight to. On a world that is nearly all one shade of dark, here is the one thing that is genuinely, definitively bright. The highest, cleanest note of light on an entire globe of shadow. Let me set the scene of that crater a little more, slowly, so you can really see it in your mind as you lie there. Wunda is not a small dent, it's a substantial bowl, about 131 kilometers across. If you could somehow set it down on Earth, it would swallow a large city and its whole spread of suburbs and still have room to spare. It sits near the equator of Umbriel, only about 6 degrees south of the middle of the moon, so almost exactly around the widest part of that dark ball. And around the floor of that great bowl runs the bright material, arranged in that soft ring shape that gives the feature its whole character. A pale annulus, a loop, a halo lying flat on the ground, far below the crater's rim, catching what little light reaches it and giving some of it back. And here is a small, strange, almost dreamlike detail about how we first saw it. One that I love for how gently it complicates everything. When the ring was photographed, the crater happened to be sitting right near the edge of the visible disk of the moon, near what astronomers call the limb, which is just their word for the curving rim of a world as you see it, the place where the lit face bends away into the dark. So we didn't get to look straight down into Wunda from directly above. We caught it at a steep, grazing angle, almost edge-on, tilted away from us and only half-lit. Seen like that, near the top of the moon's disk, at that slant, the bright floor material reads clearly as a ring, a bright arc riding the edge of the world. We have never had a clean, overhead, well-lit portrait of it. We have only ever had that one slanted, half-shadowed glimpse, which brings us, softly, to the third unknown and to the stake at the centre of this whole quiet story. When did we last see it? The answer is almost unbelievable when you sit with it. We have seen the ring on the floor of Wunda exactly once. One time. Ever. Not once a year. Not once a decade. Once, total, in the entire history of human beings looking outward at the sky. And that one time was not recent. It was on the 24th of January in 1986. That's the date of the closest approach of a single spacecraft, a robotic explorer called Voyager 2, one of the 2 Voyager probes that NASA launched in the 1970s and sent coasting outward through the solar system on a grand tour of the giant planets. Voyager 2 swept past Uranus and its moons, and in the course of that flyby, it turned its cameras on Umbriel and took the pictures that gave us the ring. And then it kept going, because that's what a flyby is. It doesn't stop, it doesn't circle, it doesn't come back. It falls past at enormous speed, gathering everything it can in a matter of hours, and then it's gone, on outward, into the dark. And the moon is left behind, alone again. So everything we know from close-up about the surface of Umbriel, the darkness, the craters, the one bright ring, comes from a single spacecraft on a single day, nearly 40 years ago, as I speak to you now. No spacecraft had ever visited the Uranus system before Voyager 2 arrived, and in all the years since, No spacecraft has ever gone back. Not one. That whole distant family of moons has had exactly one visitor in all of human history, and that visitor stayed only a few hours, and then it left. When you look at a picture of the bright ring in Wunda, you are looking at light that was gathered in a single afternoon, so to speak, decades ago, by a machine that is now far beyond the edge of the planets and will never point its cameras that way again. Let that settle over you like a quiet weight, the good kind, the kind that presses you gently down into the mattress. We are talking about one of the darkest large moons in the solar system, and one genuinely mysterious feature on its surface, and the entire close-up record of it amounts to a few hours of one long ago, January. That's part of why nobody can fully explain the ring. It isn't only that the physics is hard, though it is, it's that we have barely met this world at all. We have shaken its hand exactly once, in passing, in poor light, and never seen it again. And it gets softer and stranger still, because even during that one brief visit, Voyager 2 could not see all of the moon. It saw only part of it. By the best reckoning, the spacecraft managed to photograph only around 40% of Umbriel's surface. 40%. Which means that more than half of this world, the greater part of it, has never once been seen by any camera, human or robotic, ever. There are whole regions of Umbriel, vast stretches of that dark surface that no eye and no lens has ever looked upon. They are as unseen tonight as they were before we were born. For all we know, there could be another ring out there. There could be a dozen. Or Wunda's ring could be truly, perfectly alone, the single bright thing on an entire world. We simply cannot say, because we have never looked at the rest of it. I'll tell you later, when we're even deeper into the night, exactly why Voyager 2 could only see that one slice of the moon, because the reason is itself a beautiful and slightly dizzying thing about the whole Uranus system, having to do with the way that planet lies, tipped over on its side as it rolls around the sun. It's a lovely fact, and I'll unwrap it slowly when we get there. For now, just hold the shape of it. One spacecraft. A few hours. Long ago, and less than half the moon seen even then. That's the true reason the word unexplained in this story is honest and not a trick. It's not that someone is keeping the answer from you, it's that the answer is written across a surface we have mostly never looked at, glimpsed once, at a slant, in the dark. That's the whole promise of tonight, and I want to make it to you plainly so your mind knows exactly what it's being invited to do. We are going to descend, slowly, into this one ring of light. That's all. We are not going to race around the solar system. We are not going to pile up 100 unrelated facts. We are going to stay with Umbriel and its single bright loop, and we are going to circle it gently from every soft angle. We'll sit for a while with the darkness itself and why a world can turn out so black. We'll sit with the crater and the strange grazing way we saw it. We'll sit with the honest, careful, competing ideas that real scientists hold about what that pale material actually is, whether it's a frost, whether it's fresh ice dug up from below, whether it's something stranger. And we'll hold each idea up to the faint light and turn it over without ever pretending we've settled it, because we haven't. And we'll let the newest clue, from a great telescope that has only recently turned its eye toward these moons, deepen the mystery rather than close it. And if, somewhere along the way, you fall asleep, mid-crater, mid-thought, mid-descent, then good. That's exactly what this is for. You do not have to reach the end. There is no end you have to reach. The ring will keep glowing on the floor of Wunda, whether you follow me all the way down or not, the way it has glowed, presumably, for a very long time, seen only that once, waiting patiently in the dark for the next time anyone comes to look. Let me linger a little longer on the feeling of the place, because that's the part that will carry you off, more than any number. Try, as you lie there, to really be there for a moment, standing on the floor of Wunda. It's an impossible thing, of course. You would need a suit and warmth and air and a way to have crossed all those billions of kilometers of dark. But in your mind you can do it easily. And it costs nothing. So stand there. Above you, the walls of the crater rise up and away, a rampart of dark grey material curving around you in a great ring, 131 kilometers wide, so far off in places that its rim would sit low on the horizon. The ground beneath your feet is dark and old and still, and running across that ground, near you, is the pale material, brighter than everything else, a soft band of light in the endless grey. The sky above you is almost entirely black because you're so far from the sun that even at noon the light is thin and the darkness between the stars is deep. And low in that sky, enormous, would hang the pale blue-green face of Uranus itself. The planet this moon has circled for billions of years, silent, banded faintly, tipped over on its side. No wind touches you, because there is no air to carry a wind. No sound reaches you, because there is nothing to make one and nothing to carry it. It is one of the stillest, quietest places you could ever imagine standing. Colder than any cold you have ever felt, darker than any dark you have ever seen. And there, at your feet, is one ring of gentle brightness, glowing softly, keeping you company in all that shadow, the way a single nightlight keeps a child company in a big dark room. That's the image I want you to sink into tonight. Not fear of the dark. The opposite. A dark so complete, so ancient, so untroubled, that the single point of light within it becomes something to love rather than something to solve. The whole vast, cold, patient stillness of it, and one soft ring holding its small brightness in the middle. There is nothing threatening out there. Umbriel is not going anywhere. It has been circling Uranus, slow and steady, since long before there were people to name it. And it will go on circling long after tonight is forgotten. It is one of the most peaceful, unchanging places in all creation. Nothing happens there quickly. Nothing happens there loudly. It is, in a way, the perfect thing to think about as you let go of a day that probably had far too much happening in it, far too quickly, far too loudly. Because I know why you're here. I know that some of you are listening not because you're merely curious, but because the dark of your own room at this hour hasn't been kind to you. Because the mind, left alone in the quiet, has a way of running over the day just gone, over the day to come, over the thousand small, unfinished things, and won't seem to settle. If that's you tonight, then I want you to try something gentle. Every time you notice your thoughts starting to run again, off toward tomorrow, off toward some worry with teeth in it, I want you to bring them, softly, without any effort, back to the ring. Back to that one pale loop of light on the floor of Wunda. You don't have to force anything away, you just have to have somewhere calm to return to. And tonight, that's your place. One ring. One quiet light. On a world so far off and so still that all of your day, everything that felt so urgent, is smaller than a whisper against it. Let me tell you the name of the moon a little more slowly, because even the name is soft and dark and fits the mood. Umbriel, It's an old name, chosen long before anyone knew this moon would turn out to be the darkest of its family, and yet it fits so well that it feels almost like a small piece of quiet magic. It was borrowed from a poem, an Old English poem, written back in the early 1700s by a poet named Alexander Pope, a light and playful mock epic called The Rape of the Lock. And in that poem, Umbriel is a character, not a person exactly, a spirit, a dusky, melancholy little sprite, a creature of shadow and gloom, drawn to dim and shaded places. When astronomers came to name this moon, more than a century after the poem, they reached for that shadow sprite. And so, entirely by chance, or perhaps by some quiet poetic rightness, the darkest large moon of Uranus ended up carrying the name of a spirit of shadow. The root of the word itself reaches back to an old Latin word for shade, for the soft dimness cast where the light doesn't reach. A shadow's name, given to a shadow's world before anyone knew, and the craters on Umbriel carry that same theme onward, which is its own small comfort of consistency. The people whose job it is to name the features of the moons of Uranus decided, for Umbriel, to name its craters after dark spirits and gloomy figures drawn from myths and folklore all around the world. So the moon's map reads like a soft roll call of shadows. There is Wunda, our bright ringed crater, itself named for a dark spirit from Australian Aboriginal tradition. And there are others scattered across the parts of the surface we've seen, craters called Malingi, and Setibos, and Skinned, and Vuva, and Zliden, each one named for some spirit of dark or of ill from one tradition or another. A whole quiet company of shadows written across a shadow world. And I love, more than I can quite say, that the single brightest thing on this entire moon of shadows sits on the floor of a crater named for a dark spirit. Of all the places for the one point of light to be, it is inside Wunda, inside a bowl that bears the name of a creature of darkness. As if the dark itself were cupping the light in its hands and holding it up for us to see. It's the kind of small, accidental poetry that the real solar system hands you now and then, if you go slowly enough to notice it. There's no meaning in it, of course. The universe didn't plan it. The names were chosen by people, the ring was placed by physics, and the two only happened to sit together. But at this hour, half asleep, you're allowed to enjoy it anyway. A world of shadows, named for a shadow, cradling one ring of light in a crater named for the dark. So that is where we are tonight, and that is where we'll stay. Far out past the ringed giant, past the great striped worlds, out at the edge of the planets, at a pale tipped-over planet called Uranus, at one of its 5 large moons. The darkest of them, Umbriel, the shadow sprite made real. A coal grey ball of ancient ice and rock, about 1,169 kilometres across. And on that dark and quiet face, near the equator, on the floor of a bowl called Wunda, 131 kilometres across, there is a soft ring of pale, bright material, the single most reflective thing on the whole world, glowing gently against the dark. We have seen it once, on the 24th of January, 1986, from a passing spacecraft called Voyager 2, which stayed only a few hours and photographed less than half the moon before continuing on into the outer dark, never to return. And in all the time since, no one has been back, and no one can fully say what the ring is, or why the moon that holds it is so uncommonly dark, or what lies waiting on the more than half of that world that no camera has ever seen. 3 soft unknowns, then, what the ring is, when we last saw it, why the world is so black. We have already touched the second one, gently. We saw it once, long ago, and briefly. Over the rest of our slow descent tonight, we'll circle back to the other two, again and again, and hold them up to the thin far light, and turn them over slowly, and never once force them shut. Because the honest truth is that they aren't shut. And there is something deeply restful in a mystery that no one needs you to solve. You can lay it down beside you like a smooth, cold stone from a riverbed. Something to hold, something to turn over in your fingers, something that asks nothing of you but that you notice it and let it be. So let's begin our descent, slowly, together, into that one ring of light. Let's start, in a little while, with the darkness itself, with why a whole world can turn out so black, and what the careful people who study these things think might have painted Umbriel in shadow. But before we go there, just rest a moment more with the picture as a whole. The dark ball hanging in the far twilight, the pale planet looming beyond it. The great cold bowl of Wunda near the equator. And on its floor, faint and patient and utterly quiet, the one soft ring of light, waiting in the dark exactly as it has waited all this time for the next set of eyes to come and find it. Keep your own eyes on that light if you're still with me. Let everything else go dim around it. And let's go down, slowly, into the story of the darkest moon of Uranus and the single bright ring that no one can explain. The darkness, then, let us begin there. Because the darkness is not incidental to this story, it is the story, or at least half of it. The ring of light means nothing, cannot be properly felt or understood or wondered over until you understand what it is glowing against. And what it is glowing against is something very close to the most complete and uniform darkness that any large moon in this solar system presents to the sun. When scientists measure how reflective a surface is, they use a number called albedo, which comes from the Latin word for whiteness. An albedo of 1 means a perfectly mirrored surface, one that bounces back every photon that touches it. Wastes nothing, reflects everything. An albedo of 0 means a perfectly black surface, one that swallows all incoming light and offers nothing back. Fresh snow is somewhere around 0.8 or 0.9 on that scale. The moon you see on clear nights from your window, bright as it sometimes seems, sits at around 0.12. Asphalt on a road in summer, the flat grey black of a parking lot at noon, is roughly 0.4. Umbriel's geometric albedo is approximately 0.26. That sounds at first like it might be middling, a surface neither especially dark nor especially bright. But context is everything in this kind of number, and the context here is the other 4 large moons of Uranus, Ariel, Umbriel, Titania, Oberon, Miranda, 5 worlds that formed together from the same disk of material swirling around the same young planet, built from similar ingredients, sitting in similar conditions of cold and shadow and radiation. Among those 5, Umbriel is the odd one. It reflects around half as much sunlight as Ariel, which is the brightest of the group. Half, 2 surfaces, made of comparable materials, orbiting the same planet, and one returns roughly twice as much light to the sky as the other. That is not a subtle difference. That is the difference between a face and a shadow, where a face should be. There is a second albedo number, called the bond albedo, which captures something slightly different. Not just how bright a surface looks from a particular angle, but how much total light energy it actually reflects in all directions combined. The number relevant to its energy balance. How warm or cold it runs. Umbriel's bond albedo is approximately 0.10. That places it, in terms of total reflectivity, not far above a road in summer. The sunlight that travels the roughly 3 billion kilometers from the sun to Uranus and then falls on Umbriel, already thin and pale, already a shadow of the sunlight you would feel on your arm, is almost entirely absorbed, swallowed, gone into the surface without returning. And the remarkable thing, the thing that the Voyager 2 images made clear in 1986 when they came back and the scientists began to study them, is that this darkness is not patchy. It is not the darkness of a surface, with bright regions and dark regions, light highlands and shadowed low valleys. Umbriel is, in the images Voyager returned, a nearly uniform dark grey from one horizon to the other. There is very little differentiation. What craters are visible, and there are many, appear in slightly different shades of the same pervasive coal-dark tone. The surface does not vary the way other moons' surfaces vary. It is as though something painted it, carefully and completely, in the same grey-black, all over, from pole to pole. The dark is comprehensive in a way that makes the one bright ring in Wunda not merely unusual, but starkly, almost impossibly conspicuous. On Ariel you might not notice one bright patch amid others. On Umbriel there are no others to blend it in. Nobody fully agrees on why. This is worth sitting with. 5 moons formed together, and one came out this dark, and the careful, patient scientists who have spent years studying what Voyager's cameras sent back, who have analysed spectra and modelled surface chemistry, and debated the physics of what happens to ices and rocks at these temperatures and under this radiation, do not have a single clean answer for why Umbriel is so much darker than its siblings. There are several ideas, each with real evidence behind it, each with real gaps in the evidence behind it. The first idea is the oldest and simplest, a dark veneer. Imagine that over immense spans of time, material fell onto Umbriel's surface from outside, dust, micrometeorites, the fine dark debris that drifts through the outer solar system, carbonaceous grains shed by passing comets, particles of processed organic material from Uranus's ring system or from the other moons. Imagine that this material, dark as soot, settled slowly and evenly onto the surface, the way fine dust settles in a room no one has entered in a long time. Over hundreds of millions, perhaps billions of years, even a thin accumulation of very dark material could coat the ice underneath. Just as a thin film of grime on a window can dim the light through it far more than you'd expect from how thin the film actually is. The ice beneath might be clean and reflective. But it would not matter, because what you'd see from outside is the dark coat on top. And if that coat were mixed enough into the surface, if impacts churned it in over geological time, if radiation baked it in, if it became not a separate layer, but an intimate mixing throughout the regolith, then it would darken the whole surface in a way that no amount of fresh cratering would fully undo, because even freshly exposed material would contain the dark contaminant mixed throughout. There is something slightly uncomfortable about this idea, not because it is wrong, but because it is hard to pin down. It explains the darkness without specifying exactly what the dark veneer is, where it came from, or why it would have fallen more heavily on Umbriel than on Ariel, which sits closer to Uranus and might be expected to receive even more infall from the region around the planet. The idea raises the question without fully answering it, which is perhaps fitting for a moon that specializes in half-answers. The second idea goes deeper into Umbriel itself, deeper in time, not just in space. This idea suggests that Umbriel's darkness is not something that arrived on top, but something that was always there, baked into the material from which the moon formed. Out in the cold of the outer solar system, certain kinds of carbon-rich, rocky, organic material have always been dark. Carbonaceous chondrite meteorites, the oldest, most chemically primitive rocks that fall to Earth from space, among the first solid objects the early solar system made, are typically very dark, with albedos around 0.03 to 0.06, darker even than Umbriel. The outer solar system, at the time the Uranian moons formed, was full of this kind of material: carbon compounds, organic molecules, tarry residues of chemistry that had been going on for millions of years in the cold dark between stars. If Umbriel's original building blocks contained more of this dark, primitive, carbonaceous material than Ariel's did, either by chance in the disk from which they formed or by some process that sorted materials differently at different orbital distances, then the moon might have come out of formation already darker, and remained darker ever since, because there was nothing inside it to erase that darkness. This idea, too, has an attractive quality. It fits with what the mass and density tell us. Umbriel's mean density is approximately 1.4 grams per cubic centimetre, meaning that if you could fill a cubic centimetre with Umbriel stuff, it would weigh about 1.4 grams, which is heavier than pure water ice, but lighter than pure rock. The density implies Umbriel is made of roughly comparable portions of water ice and denser material, rock and dark carbonaceous compounds mixed in. That dark rocky fraction was always there. It was always part of what the moon is. The question is only whether it is the primary reason for the surface darkness, or whether surface processes have amplified it. And the third idea is perhaps the most chemically specific, and in many ways the most evocative of the three. This idea involves something that sounds almost biological, but is not: a class of organic compounds called tholins. A word coined by the planetary scientist Carl Sagan and his colleague Bishun Khare in the 1970s, derived from the Greek word for muddy. Tholins are complex, dark, reddish-brown organic residues that form when ultraviolet light or charged particles, radiation, in other words, bombard simple ices like methane and nitrogen and water. You can make them in a laboratory. You can hit a cold flask of methane ice with enough ultraviolet light and watch the flask walls slowly coat with a dark, sticky residue, the chemistry of deep space recreated at a bench in a building on Earth. In the outer solar system, that same chemistry runs continuously. Methane ice on a moon's surface sits in constant radiation, solar ultraviolet light, however thin at that distance, still arrives and still does work, and the charged particles trapped in a planet's magnetosphere arrive constantly, energetic protons and electrons bombarding anything in their path. When this radiation hits methane-bearing ice, it can break apart the methane molecules and reassemble the fragments into heavier, darker, more complex organic chains, tholins and related compounds, that accumulate in the surface over time, darkening it progressively, like the ice is slowly being stained from the outside in. The longer a surface sits exposed to this radiation, without being refreshed by geological activity, without eruptions of fresh material from inside, without tectonic resurfacing that brings clean ice up from below, the darker it gets. And Umbriel, by every indication in the Voyager images, is very old. It is the most heavily cratered and geologically ancient-looking of the 5 major moons. It shows almost no sign of the kind of geological resurfacing that rejuvenates a surface, none of the smooth volcanic plains that suggest material has welled up from inside. None of the canyon systems or extensional faults that suggest the interior once flexed and cracked and renewed what was on top. Ariel, by contrast, shows clear signs of geological activity in its past: smooth regions, long valleys, places where material from inside seems to have flooded the surface and covered older craters, making those regions younger looking and brighter. Miranda, the smallest of the five and the innermost, is a chaotic patchwork of different terrain ages, as though something once broke it apart and reassembled it, or drove intense geological convulsion through it. Titania and Oberon show signs of at least some geological activity in their histories. Umbriel shows almost none. Its surface, as Voyager revealed it, is a dense, ancient field of craters. Impact after impact after impact, accumulated across something like 4 billion years of solar system history. No plains of younger material covering the old craters over, no canyons cutting across them in patterns that would indicate later stretching. Just the craters, and between the craters, older cratered terrain, and under all of it the sense of a world that long ago went still, cooled, and simply stayed that way. Unchanged on the outside, bombarded by the slow, patient accumulation of space debris arriving over geological time, and by the steady radiation that slowly darkened every exposed grain of ice and rock on its surface. Year by year, million year by million year, until the whole globe reached this deep, even, nearly uniform grey. Diameter 1,169 kilometers. A world of considerable size, not a small rock, not a chip of ice, but a body nearly as large as some of the smaller dwarf planets, as wide as half the continental United States from coast to coast. And yet in all that diameter, in all that surface, across what would be an enormous landscape if you could somehow stand on it and walk it, almost nothing changes in reflectivity from one region to the next. The darkness is comprehensive in the way that silence is sometimes comprehensive, not the absence of a sound here and there, but the actual presence of quiet filling the whole space, from all directions, leaving no surface untouched. Whatever painted Umbriel did a thorough job. And the frustrating, honest, rather comforting answer of science on this point is, we are not entirely sure which of these mechanisms painted it, or whether it was all of them working together over immense spans of time, layering darkness on darkness. The dark veneer and the dark composition and the dark chemistry of radiation all conspiring to produce the darkest large moon of Uranus. The honest answer is that we do not know. It is a genuinely open question among the people who study these things carefully, and perhaps that is not surprising, because to fully answer it, you would need to do what Voyager 2 only barely began to do. You would need to orbit Umbriel, study it across multiple wavelengths, take spectra that could separate the composition of the dark material, map where the darkening is deepest and where it thins, and why. We have done none of that. We have one flyby, one visit, 40 years old and change, and the surface of Umbriel is dark, for reasons we can name and argue over, but cannot, with the data we have, fully confirm. Now, the name. There is something worth pausing on here. In the slow way this kind of story asks you to pause, turning a detail over in the mind the way you might turn a smooth stone over in your hand, feeling its weight and its surfaces before setting it down. Umbriel, this dark, still, ancient cratered world, the shadow moon of Uranus, was given its name because of a poem. In 1751, the English astronomer William Lassell published his discovery of the moon, which he had found with his own telescope, a 24-inch reflector that he had built and paid for himself with the proceeds of a business in brewing beer. Lassell was a gentleman scientist of the 19th century, gifted with both practical talent and the financial means to pursue it without institutional support. And on the night of 24 October 1851, a Tuesday, by the calendar, he picked up 2 new moons of Uranus in his eyepiece, this one and Ariel, both discovered on the same night, both entirely unseen before that moment in all of human history. The 24-inch reflector, the Brewer's telescope, was good enough to see things that had waited undiscovered in the outer solar system for the full span of human civilization. That is its own kind of quietly remarkable fact. Lassell asked John Herschel, the son of the astronomer who had discovered Uranus itself, to suggest names, because the convention for Uranian moons was already taking shape. A naming tradition drawn not from classical mythology, but from the plays of William Shakespeare and the poetry of Alexander Pope. The moons of Uranus would carry names of sprites and spirits and fairies, Oberon and Titania from A Midsummer Night's Dream, Ariel from The Tempest. And so Herschel looked and found and named the darker of the 2 new moons after a character in Pope's poem, The Rape of the Lock. The Rape of the Lock was published in 1712, a mock heroic poem in which Alexander Pope satirized a trivial social scandal by treating it in the elevated style of ancient epic poetry. The poem is full of supernatural machinery, sylphs and gnomes and spirits who inhabit the metaphysical world around the poem's social world. Umbriel in the poem is a dusky, melancholy gnome associated with shadow and gloom, the counterpart to the brighter and more playful Ariel spirits. In Pope's lines, Umbriel descends to a realm of darkness and brings back a bag of sighs and a phial of sorrows, instruments of melancholy and shadow. It is not a heroic character. It is a spirit of dimness and heaviness, of downward movement and shade. And then, more than a century after the poem was written, a moon turned out to be the darkest large moon of Uranus, and it was already wearing that name. The word umbra in Latin means shadow. Umbral regions in astronomy are the dark cores of shadows, the places where a body completely blocks the light and full darkness falls. Umbriel, named for the shadow gnome by a kind of coincidence that feels almost too neat, turned out to be the most shadowy of the 5, the darkest, the most ancient, the most uniformly coal-dark of the major moons. The name arrived first, and reality confirmed it, which is the kind of pattern that tends to stick in the mind when you are lying still in the dark and letting stories happen inside you. Planetary scientists, when they name features on new worlds, tend to follow thematic conventions, each moon's features named for a related class of things, so that the naming gives the landscape a coherence, a flavour. For Umbriel, the convention is almost perfectly designed for the moon it describes. The craters of Umbriel are named for dark and malevolent spirits from mythologies around the world. Wunda, the 131-kilometre crater that holds the bright ring, takes its name from a dark spirit in Australian Aboriginal tradition. Malinghi, another crater, is named for a malevolent spirit from the folklore of South Australia. Setebos, a name from Patagonian mythology, is a dark god mentioned in Shakespeare's The Tempest. Skind is a spirit of darkness. Vuva is a Finnish demon. Zliden, from Slavic mythology, is a spirit of misfortune. Gob, Peri, Kanaloa, from Polynesian tradition, a spirit of the deep. A whole world of craters named for darkness. A landscape whose features speak, in name after name, of shadow and misfortune, of the dark things from the folklore of cultures separated by oceans and centuries, but united by the ancient human awareness of what lives in shadow. And in the middle of all that, in a crater named for a dark spirit of the Australian tradition, there is a ring of light, the one bright feature on a world that was named, from the poem and in every crater, for everything that is not bright. The ring sits in Wunda, and Wunda is named for something dark. And that is, when you let yourself feel it slowly, a strange and resonant thing. Not a scientific fact, not a mechanism, but a coincidence of language and geography that takes on a quality, in the listening, of something almost deliberate, as though the moon were illustrating its own nature through the names it wears. One pale loop of light in a crater named for a dark spirit, on a world named for a shadow, in the mythology of several different human cultures, and all of it settled into place before the ring was ever seen, before the crater was ever named, before the names even existed. Because the ring was there first, has been there for geological time, patient and still, waiting for a flying machine called Voyager 2 to pass by in January 1986 and capture it in a photograph for the first time. It does not explain anything. The poem does not explain the darkness of the moon. The crater's name does not explain the ring. These are accidents of naming, coincidences of language meeting the real world. But there is a kind of restful pleasure at this hour in letting the coincidence breathe, in noticing that when the naming traditions caught up with the reality, they fit with an uncanny completeness. Umbriel, the shadow. Its craters, Mallingi, Setibos, Skind, Vuva, Zleden, and in Wunda, named for a dark spirit of the southern traditions, one unaccounted for brightness. One ring of something pale and reflective, standing out against the cold dark floor like a halo with nowhere to go. The crater names are a kind of poem themselves, a catalogue of the world's dark spirits gathered on a single dark moon. And if you say them slowly enough, Mallingi, Setibos, Skind, Vuva, Zleden, they become almost musical, a slow low list, a naming of the shadows. And the whole world takes on the quality of a place that the mythologies of Earth have half described without knowing it, a dark place, old and cold and still, on which something bright has appeared without explanation. Umbriel is, in terms of the scientific classification of moons, what geologists would call a dead or geologically inactive body, not dead in the dramatic sense. Not silent in any literal sense, but dead in the sense that its interior is almost certainly too cold and too differentiated, too settled and crystallized over 4 billion years to generate the kind of heat that would drive geological activity at the surface. In the early solar system, many moons were warm. They had been assembled from colliding material. And that collision energy took time to radiate away. They had radioactive elements in their rock that released heat as they decayed. Some were warmed by tidal forces from their planet's gravity, stretched and squeezed in their orbits in a way that generated internal friction and heat. But those heat sources fade. Radioactive elements decay away. Orbital mechanics can quiet down. And a moon that no longer has sufficient internal heat becomes still. Its interior cools and hardens. No eruptions well up from inside. No ice water slurry reaches the surface to resurface old craters and make fresh new terrain. It simply sits there and accumulates more craters on top of the old ones, the surface growing older and more battered and darker as the radiation slowly works. Umbriel sits there and accumulates, and that accumulation is the geological fact behind the aesthetic one. The uniform darkness is the record of time, time without renewal, time without resurfacing, time during which the same surface has sat exposed to the same radiation field and the same slow rain of debris, slowly being painted in all the chemistry that exposure to the outer solar system produces. The density of craters on Umbriel. a 169-kilometer body covered more completely in impact scars than any of its siblings, is the clock that tells you how long this has been going on. More craters means more time exposed. More time exposed means more radiation chemistry. More radiation chemistry means, very possibly, more of whatever process darkened the surface to begin with. The diameter, 1,169 kilometers. That number is larger than it sounds. The state of Texas is roughly 1,200 kilometers across from east to west. So if you could pick up Texas and turn it into a sphere, not just the surface area, but a full sphere with volume, you would have something close in size to Umbriel. A whole dark world the size of a state, floating in the cold around Uranus, orbiting at about 266,000 kilometers from the center of the planet, completing one full orbit every 4.14 days. Going around and around, silently, in that deep cold that makes the air of Antarctica feel tropical by comparison. And the mass and the density, approximately 1.2 times 10 to the 21st kilograms, and approximately 4 grams per cubic centimeter, those numbers are telling a quiet story too. A density of 1.4 is meaningfully heavier than water ice, which lands at 1.0. It means that inside Umbriel, ice does not account for all the mass. Something denser is there, rock and likely dark carbonaceous material, the kind of primitive rocky organic stuff that is itself among the darkest materials the solar system makes. So when scientists estimate what Umbriel is made of, roughly comparable portions of water ice and dense rocky dark material, they are describing, in those proportions, a world that carries darkness built into its very composition, not just painted on top. The darkness is structural as well as chemical. It is embedded in what the moon is, not merely what its surface has become. And yet the ring in Wunda glows. Against all of that, against the ancient surface chemistry, against the radiation, darkened regolith, against the uniform coal grey that 4 billion years of exposure have produced, against the catalogue of shadow-named craters and the shadow-named moon and the shadow gnome from Alexander Pope's poem, against all of that, one pale ring of material on the floor of a 131-kilometre crater sits and reflects light back into the dark. It is not merely brighter than average. It is by far the brightest thing on the entire moon, the highest albedo feature, the most reflective spot, the only place on Umbriel that catches the thin, distant sunlight and sends a meaningful portion of it back out into space. It asks, quietly but unmistakably, why me? Why here? What has happened in this crater that did not happen everywhere else? What is this ring made of, and how did it get there, and why does it still glow, alone, on the darkest large moon of Uranus? These are the questions we are descending toward. These are the questions that the people who have studied these images have carried with them since 1986, and that the data from the James Webb Space Telescope, arriving decades later, have added new texture to, without fully resolving. The questions remain open, and in their openness they have a quality, like the darkness of the moon itself, like the silence between the crater names, like the way the ring glows faint and patient in the Voyager image, of something that does not need to be rushed. There is a kind of question that demands resolution. That keeps the mind running hot until it finds the answer, and there is another kind, rarer, and in its own way more valuable, that can be held quietly, turned over slowly, sat with in the dark without urgency. Umbriel's ring is the second kind. It is a mystery that belongs to the category of honest unknowns, the things that science has looked at and said, genuinely, we are not yet certain. And here is why. Not because no one has looked, but because the only looking we have managed so far was brief and partial and far away and long ago. It is a mystery built from the limitations of what we have been able to do, as much as from anything intrinsically unknowable about the ring itself. And that kind of mystery, when you can recognize it as such, carries with it something almost like comfort. The comfort of knowing that the not knowing is honest, that it does not reflect a failure of care or intelligence, only the specific, hard, slow work of trying to understand something that is 3 billion kilometers away and which we have visited exactly once. The names of Umbriel's craters, all those dark spirits collected from the world's mythologies, feel like an accidental poem about this. Malingi and Setibos and Skind and Sliden and Vuva gathered on one still and ancient dark world, and in Wunda the one bright thing. Perhaps the names are saying something that they did not intend to say, that even on the darkest surfaces, in the deepest shadows, in a place named for gloom, and its craters named for every tradition's understanding of the night, something unexplained persists in being bright. That persistence is what the next part of our descent will take us toward. We've been here, in the darkness, in the composition, in the names and the ancient craters and the radiation-painted surface that no one has fully explained. And now, slowly, we will begin moving toward the ring itself, toward the one flyby that captured it, toward the constraints of that single glimpse, toward the questions of what the ring could possibly be, and why each answer, plausible as it is, remains just short of proven. But not yet. Not quite yet. For now, rest with the darkness itself, the nearly uniform dark grey. The bond albedo of approximately 0.10, swallowing light from a sun already 3 billion kilometers away. The ancient craters piled on older craters, the surface that did not renew and did not refresh, that simply sat, patient and cold and still, being slowly darkened further by the chemistry of radiation, acting on methane ices over geological spans of time that no human life can directly imagine, only stand before, in imagination, and be quietly humbled by. Umbriel has been dark for a very long time, longer than anything alive on Earth has existed, longer than most of the geological features you could name. The darkness is not new, and it is not accidental, and it is not, if the science is right, the result of any single cause, but of several causes layering over one another across billions of years. And the ring has been bright, presumably, for a very long time too, sitting in Wunda, catching what light arrives, glowing its quiet pale glow against the dark floor of the crater. Surrounded by the darkness that is everywhere else on Umbriel, indifferent to it, or perhaps simply unaware of it, in the way that a point of light cannot know how dark the world around it is. That ring has been waiting in Wunda for a very long time. We saw it once, in 1986. For a few hours, from a spacecraft that was just passing through. And that fact, simple as it sounds when stated plainly, is one of the stranger things about this whole mystery. Because when you sit with it long enough, you begin to understand that what we are dealing with here is not quite the same as a puzzle with all the pieces on the table and simply the answer missing. What we are dealing with is something more like a puzzle where most of the pieces have never been looked at. Where the box arrived sealed and we opened one corner of it for a few hours in January of 1986, and then the box was taken away and has not come back. The constraint here is not only one of interpretation, it is one of observation itself. And that changes everything about how honestly we can hold the question. To understand why we have seen so little of Umbriel, why that single glimpse from Voyager 2 was so partial, so geometrically awkward, so constrained by circumstances beyond any engineer's control, you have to go back to Uranus itself, to the planet that Umbriel circles, to the tilt. Uranus is tipped over, not leaning slightly, the way the Earth leans at about 23 degrees to give us our seasons. Not inclined at a modest angle, the way Mars is or Saturn. Uranus is tipped onto its side. Its axial tilt is approximately 98 degrees, which means that relative to its orbital plane around the Sun, Uranus rolls along on its side like a barrel, its poles pointing roughly toward and away from the Sun, rather than up and down the way you might expect a well-behaved planet to orient itself. The equator of Uranus runs nearly pole to pole from the Sun's perspective, and its seasons are unlike anything in the inner solar system. Each pole of Uranus gets roughly 42 years of continuous sunlight, and then roughly 42 years of continuous darkness. As the planet makes its long, slow journey, 84 Earth years, 1 Uranian year, around the Sun. No one is entirely certain how Uranus came to be tipped this way. The leading idea is a catastrophic collision early in the solar system's history with something very large, something massive enough to knock the planet sideways and leave it rolling. But the details of that collision, if it happened, are not known. What is known is the result, a planet oriented so differently from its neighbours that visiting it with a spacecraft requires planning not just for position in space, but for the geometry of time. And in January of 1986, when Voyager 2 arrived, Uranus was positioned in its long orbit such that its south pole was tilted toward the Sun. It was, in the language of planetary astronomy, near southern solstice. The southern hemisphere of the planet and the southern hemispheres of its moons were bathed in sunlight, if you can call the pale, distant, attenuated light that reaches 3 billion kilometers from the Sun bathing in anything. The northern hemispheres of all those bodies were pointed away from the Sun and away from Voyager 2, and they were sitting in polar darkness. Not twilight, not dim light. Darkness, this is not a small detail. This is the architectural constraint within which everything we know about Umbriel was gathered. Voyager 2 could only image what was lit, and what was lit on Umbriel in January 1986 was the southern hemisphere and a portion of the equatorial region. The northern hemisphere, the entire northern hemisphere, was simply dark, not photographable, not reachable by the instruments aboard the spacecraft in any useful way. It sat in its long polar night, as it had been sitting for years already, and would continue to sit for years after the spacecraft had gone, waiting out the season with the unhurried patience of something that has waited out many seasons before and expects to wait out many more. The result is that Voyager 2 imaged roughly 40% of Umbriel's total surface. 40%. That means that more than half of this moon, more than half of a world 1,169 kilometers across, ancient and dark and presumably bearing craters and features and perhaps other bright anomalies none of us have ever seen, has never been captured in any image from any human spacecraft. The entire northern hemisphere of Umbriel is, as of this moment, a blank. Not a partial sketch. Not a low-resolution survey. A true, literal blank, a hemisphere of a world that no human-made camera has ever seen in any meaningful way. When we say that Wunda and its bright ring are mysterious, when we say that the ring is unexplained, one of the things we mean, quietly, is this: we have not even seen most of the moon it sits on. We cannot know whether the ring is unique because we have not looked at the places where other features like it might exist. The mystery is partly a mystery of physics and chemistry and composition, yes, but it is also, in a very honest sense, a mystery of ignorance. Of the simple, unadorned fact that we went once, we saw what the geometry of that year's southern solstice allowed us to see, and then we left. And the northern hemisphere of Umbriel has been dark ever since, dark and unlit and unseen. There is something in that which suits this particular moon, with this particular name, in a way that feels almost too appropriate to be accidental, though of course it is. The darkness of the unseen north is no different from the darkness of Ariel's unseen north, or Miranda's, or Titania's, or Oberon's. All of the Uranian moons were caught in the same geometric trap. But on Umbriel, the moon named for a shadow spirit, the moon whose bond albedo is approximately 0.0 and whose surface is a nearly uniform dark grey, the moon that reflects barely a tenth of the light that reaches it, on this particular moon, the fact of the unseen hemisphere sits a little differently. It feels, in the imagination at least, like the moon is withholding something. Like more than half of it is still in shadow, still private, still unknown, and it does not particularly mind. Voyager 2 itself was extraordinary. A spacecraft launched in 1977 from Earth, it had already spent nearly 9 years in space by the time it reached Uranus. It had visited Jupiter. It had visited Saturn. It carried instruments for imaging, for measuring magnetic fields, for detecting particles, for analyzing the chemical signatures of atmospheres and surfaces, for listening to the radio emissions of planetary environments. Its builders had sent it outward with care and ingenuity, and the understanding that when it arrived at Uranus, it would have only hours, not days, not weeks, to gather everything it could before its trajectory carried it onward and away. Closest approach to Uranus was on 24 January 1986. That date is worth holding for a moment. January 1986. Most of the people who built Voyager 2 had been working on it for the better part of a decade by then. The spacecraft had travelled past the asteroid belt, through the radiation belts of Jupiter, past the rings of Saturn, across the cold and largely empty space between the outer planets, and it arrived at Uranus at a precisely calculated moment that engineers on Earth had been working toward since before some of the people reading about this story were born. And in the few hours that Voyager 2 had to look at the Uranian moons, it took the images that remain, to this day, the only close images we have of Umbriel. Of those images, the one that matters most for our purposes is the one showing the equatorial region of Umbriel near its limb, near the curving edge of the disk, as seen from Voyager's angle of approach. Because Wunda crater sits near the equator at approximately 6 degrees south latitude, and because of the geometry of the flyby, Voyager 2 caught Wunda not face-on, not from directly above, but nearly edge-on, close to the limb of the moon. The crater and its bright ring were near the boundary between the lit and unlit sides of Umbriel as seen from the spacecraft. The result of this geometry, of catching a crater with a bright feature nearly edge-on near the limb, is that the bright ring inside Wunda reads in the images not as a flat circle or a pool of light, but as an annulus, a ring, a pale loop curving around the crater floor, bright against the dark surface of Umbriel, positioned near the top of the disk in the images as though Umbriel were wearing a single quiet halo near its visible edge. It is partly a trick of perspective. Not a fabrication, the bright material is genuinely there, genuinely more reflective than anything else on the moon's visible surface. But the annular appearance, the ring-like quality, is partly a consequence of angle. A bright flaw in a crater, seen nearly edge-on, looks like a ring because you are seeing the far side of it, raised slightly above the nearer side, curved into an arc by the crater's geometry and your own oblique viewing position. The ring is real. The ringiness of it is, to some degree, a matter of how you happen to be looking at it, which is one more layer of complexity in a question already well supplied with complexity. Wunda itself is approximately 131 kilometers across. To give that some scale you can feel, 131 kilometers is roughly the distance from New York City to Philadelphia. It is, in other words, not a small crater. It is a significant impact scar, the kind that would have been a geological event of considerable violence when it formed, sending material outward across Umbriel's dark surface, carving a basin into the ice and rock, perhaps excavating material from below. And on the floor of this 131-kilometer crater, the most reflective feature on an otherwise nearly uniformly dark moon, sits and glows its quiet pale glow, whatever it is made of, however it came to be there. One thing that occasionally gets lost in accounts of Umbriel's ring is the discovery history, not of the ring itself, which Voyager 2 found, but of the moon, of Umbriel as a world, as a point of light noticed by human eyes looking through a telescope in the mid-19th century, long before anyone knew how dark it was, or that it bore a crater named Wunda, or that inside that crater something was pale and strange. Umbriel was discovered on 24 October 1851. The man who found it was William Lassell, an English astronomer who built and operated his own telescopes with money he made from a different profession entirely. Lassell was a brewer. He ran a brewing operation that was successful enough to fund a serious scientific passion, and the instrument he used to discover Umbriel was a 24-inch reflecting telescope of his own construction. A large and capable instrument for its era, mounted with care and used with patience. On the night of 24 October 1851, Lassell was observing the Uranian system, and he saw not one but two new moons. The other one was Ariel. Lassell discovered both Ariel and Umbriel on the same night, which is a remarkable piece of astronomical fortune, and a reminder that the sky sometimes yields its secrets in pairs. The naming came a little later, and it came not from Lassell, but from John Herschel, the son of William Herschel, who had discovered Uranus itself in 1781. Lassell asked Herschel to suggest names for the two new moons, and Herschel chose to follow the convention he had earlier established for naming Uranian moons after characters from English literature rather than from classical mythology, which had provided names for the moons of most other planets. For the Uranian system, Herschel reached for Shakespeare and for Alexander Pope. Umbriel comes from Pope, specifically from a mock epic poem published in 1712 called The Rape of the Lock, a witty, elaborate piece of satire in which the cutting of a young woman's hair becomes the occasion for an entire mock heroic drama complete with supernatural beings. In the poem, Umbriel is a gnome, a dusky, melancholy sprite associated with shadow and gloom, with melancholy and with darkness. A creature of the lower regions, of heaviness and shade. A spirit connected to the word umbra, the Latin word for shadow, from which English draws words like umbrella and penumbra. John Herschel chose this name for the darker of the two moons Lassell had found, and the darker one has, over the century and more since, turned out to be far darker than anyone in 1851 could have guessed. Not just darker than Ariel, its sibling discovered on the same night, but the darkest of all 5 major Uranian moons. The shadow sprite has the darkest face of all of them. There is, again, no meaning in this, no intention, no cosmic joke, no design. It is a coincidence of nomenclature and orbital chemistry and geological history that happens to line up in a way that feels almost pointed. Umbriel is the darkest one, and Umbriel's name means shadow, and the character Umbriel in Pope's poem is a dusky, melancholy gnome of the deep shade. It simply worked out that way. And perhaps it is the kind of coincidence that is easiest to notice and appreciate at the slow, quiet end of a long day, when the mind is not moving quickly enough to dismiss it and simply lets it be what it is. The craters on Umbriel carry on this tradition of shadow and darkness in their naming. All of Umbriel's craters are named for dark spirits, malevolent figures, shadowy presences from the mythologies of various human cultures around the world. There is Wunda, named for a dark spirit in Australian Aboriginal tradition. There is Malingi and Setibos, and Skinned, and Vuva, and Zleden, and Gob, and Peri, and Kanaloa. A geography of darkness mapped onto the most uniformly dark face in the Uranian system, where every crater carries a name that speaks of shadow or malice or the uncanny. And in one of those craters, in Wunda, the Australian dark spirit, there is a bright ring. The dark spirit wears a halo, and no one knows why. Which brings us, at last, to the question the ring itself raises, to the 4 ideas that planetary scientists have held up against it, turned over, examined, found plausible, and been unable to confirm. Each one is a genuine scientific possibility. Each one has things in its favour. Each one has things that resist it. And in the gap between the plausible and the proven, the ring continues to sit on the floor of Wunda, pale and patient, reflecting the distant light of the sun back into space. The first possibility is that the bright ring is a deposit of carbon dioxide frost, cold trapped onto the floor of Wunda crater over time. To understand this idea, you need a picture of what cold trapping means and how it works. Umbriel is a cold world, extremely cold. Surface temperatures are on the order of approximately 75 Kelvin, which translates to roughly minus 198 degrees Celsius. At those temperatures, materials that would be gases or liquids under Earth conditions are solids. Water is a hard, rock-like ice. Carbon dioxide, which is a gas on Earth at normal temperatures and pressures, is also a solid at 75 Kelvin. It is frozen stiff. But frozen does not mean entirely inert. Even at extremely low temperatures, molecules on the surface of a solid can occasionally pick up enough energy, from sunlight, from the impact of charged particles from space, from the slow vibration of the surface itself, to break free and drift away as vapor. This process is called sublimation, and it happens even at temperatures far below 0 Celsius. Carbon dioxide, being a relatively volatile solid compared to water ice, is particularly susceptible to it. A patch of CO2 frost sitting in direct sunlight on the surface of Umbriel will slowly sublimate, molecule by molecule, the frost thinning as vapor drifts away. But that vapor does not necessarily escape the moon. Umbriel's gravity is modest, but it is there, and some of the sublimated CO2 molecules will drift across the surface rather than escaping entirely. And when those molecules encounter a place that is colder, a shadowed region, a deep spot, a depression that receives less sunlight than the surrounding terrain, they may freeze back down onto the surface. They cold trap. The cold spot acts as a collector, accumulating CO2 frost from the broader surface, slowly building a deposit over long spans of time. A crater floor near the equator could work this way. A deep crater like Wunda, 131 kilometers across, would have walls tall enough to cast shadow on portions of the floor for significant portions of each orbit. The floor, shaded more than the surrounding terrain, might be a degree or two colder than the plane outside. And that small temperature difference, maintained over millions or billions of years, could be enough to concentrate CO2 frost onto the crater floor in a ring, concentrated near the walls where the shadow is deepest, accumulating slowly to the brightness we see in the Voyager images. This idea has something to recommend it beyond the theoretical mechanism. It has, more recently, a direct observational clue. Because carbon dioxide ice has been detected on Umbriel. The detection came not from Voyager 2, whose instruments were not optimized for this kind of spectral analysis of surface composition, but from the James Webb Space Telescope, which began returning scientific data in the early 2020s. Using its near-infrared instruments, researchers including Richard Cartwright and colleagues used JWEST to look at the large Uranian moons and found signatures consistent with carbon dioxide ice on their surfaces. CO2 ice was detected on the inner large moons, including Umbriel. But the distribution of that CO2 ice was not uniform. It was not spread evenly around the moon. It was concentrated, and this is the part that carries the most scientific weight, on the trailing hemispheres of the moons. The trailing hemisphere is the side of a moon that faces backward along its orbit, the side that is moving away from the direction of orbital travel. On Umbriel, as on Ariel, the CO2 ice signature was stronger on the trailing side. That pattern is a fingerprint, not of geology or ancient chemistry, but of something active, the magnetosphere of Uranus. Uranus has a magnetic field, and that magnetic field traps charged particles from the solar wind and from the Uranian system itself, the way Earth's magnetic field traps particles in the Van Allen belts. Those trapped charged particles, electrons, protons, heavier ions, spiral around the magnetic field lines and periodically collide with the surfaces of the moons that orbit inside the magnetosphere. And because the moons are locked in synchronous rotation, the same face always pointing toward Uranus, the same face always pointing away, the same side always leading, and the same side always trailing, the charged particle bombardment is not evenly distributed. The trailing hemispheres, by the geometry of how the particles drift in the magnetic field, receive a larger share of the charged particle flux. When energetic charged particles strike a surface containing carbon and oxygen, either in organic molecules or in water ice mixed with carbon-bearing material, they can break those molecules apart and drive chemical reactions that produce carbon dioxide. This process is called radiolysis, radiation-driven chemical synthesis. The CO2 you detect in this scenario is not ancient, not primordial material surviving from the formation of the moon. It is being manufactured in a quiet, ongoing way by the bombardment of Uranus's magnetosphere acting on the moon's surface chemistry, right now, on the trailing hemisphere where the flux is highest. And if CO2 is being generated on Umbriel's surface by this process, and if some of that CO2 subsequently sublimates and migrates across the surface in search of cold traps, then a shaded equatorial crater like Wunda becomes a very plausible collection point. The frost hypothesis and the magnetospheric CO2 hypothesis are not in conflict. They work together. The magnetosphere makes the CO2. The cold trap in the crater collects it. The bright ring is the accumulated deposit. This is the best supported idea in the current literature. The dress detection is real, the trailing hemisphere pattern is real, the physics of cold trapping is well established, and the location of Wunda near the equator at a latitude where the cold trap mechanism can operate is not an accident in this model. It is exactly where you would expect a frost deposit to form. All of this is true. And yet, the CO2 was detected on Umbriel as a whole, on the trailing hemisphere, in a general sense. It was not detected specifically from Wunda crater, in part because GIST, extraordinary as it is, does not have the spatial resolution to pick out a single 131-kilometer feature on a moon 1,169 kilometers across, orbiting a planet 3 billion kilometers away. The detection is real. The interpretation linking it to the specific bright ring in Wunda is a reasonable inference, not a direct confirmation. We have not looked inside the crater and found CO2 frost with a telescope. We have detected CO2 on the moon and noted that cold trap physics could concentrate it in places like Wunda. Those are related but not identical things. The second possibility is that the bright ring is composed not of frost deposited after the impact, but of material exposed by the impact itself, of fresh, clean water ice excavated from below Umbriel's surface when whatever formed Wunda struck. Umbriel's darkness, the nearly uniform dark grey of its surface, the geometric albedo of approximately 0.26, the bond albedo of approximately 0.10, is understood to be a surface phenomenon, or at least a relatively shallow one. The Moon's density of approximately 1.4 grams per cubic centimetre is consistent with a body composed of roughly comparable amounts of water ice and rock or dark carbonaceous material. There is water ice in Umbriel, in other words. The spectral signatures of water ice are there, though relatively weak, as though they are being masked or suppressed by a dark contaminant. That contaminant, whatever it is, the dark veneer, the space-weathered organic residue, the carbonaceous material, is mostly a surface layer. It is what you see when you look at Umbriel from outside. But below that surface, there may be cleaner ice, brighter ice. Ice that has not had billions of years of radiation and vacuum and micrometeorite gardening to darken it, because it has been sitting, protected, underground, beneath the layers that bear the brunt of exposure. When a large impactor strikes a body like Umbriel with enough force to carve a 131-kilometer crater, it does not just push material aside. It excavates. It digs deep. It throws material out and up in an expanding ring, and some of that excavated material comes from layers far below the surface, from depths that the dark veneer has not reached, from ice that has remained relatively pristine and reflective throughout the Moon's history. If the Wunda impactor excavated such material, some of it could have come to rest on the floor of the crater, settled there, a ring of fresher, brighter ice, paler than anything around it, standing out against the dark, weathered surface of the surrounding plain. This idea is attractive because it requires no special chemistry, no ongoing process, no source of new material. It requires only that the impact happened, and that the material below Umbriel's dark surface is cleaner and more reflective than the surface itself, which is a reasonable assumption given the composition implied by the Moon's density and the spectral hints of water ice beneath the dark veneer. But here too the confirmation is absent. We have not been able to directly measure the composition of the Wunda ring from any existing observation. Voyager 2's instruments were imaging cameras. not spectrometers tuned to distinguish CO2 frost from water ice at the surface of a moon. The bright ring shows up as bright, and that is essentially all Voyager 2 was able to tell us about it in the few hours of closest approach. Whether that brightness is the brightness of water ice or CO2 frost or something else entirely, the Voyager data cannot say with precision. And JWST, which can speak to composition but not to the resolution of a single crater on a distant moon, gives us the general CO2 distribution but cannot zoom to Wunda and say, yes, this is water ice here, or no, this is definitely CO2 frost. The distinction matters. If it is freshwater ice, that speaks to the history of the impact itself and the structure of Umbriel's interior. If it is CO2 frost, that speaks to an ongoing, active process driven by the magnetosphere. These are different stories about Umbriel, different things to understand about how this moon works, and the ring, glowing there patiently in Wunda, has not yet told us which story it belongs to. The third idea is that the bright ring is neither frost deposited from above nor clean ice excavated from below, but rather unusual impact ejecta. Material thrown out by the Wunda impact that is compositionally different from the bulk of Umbriel's surface in some way that makes it more reflective. Not necessarily fresh ice from depth, and not necessarily CO2 frost from the magnetosphere, but material from the impactor itself, or from a specific layer within Umbriel that the impactor happened to punch through, that settled on the crater floor with different optical properties than the surrounding surface. This idea is harder to make specific, which is both its weakness and, in a way, its honesty. We do not know exactly what composition would produce ejecta significantly brighter than the surrounding surface, but we also do not know enough about the structure of Umbriel's subsurface layers to rule it out. The moon's interior is essentially unmapped. The 40% of the surface that Voyager imaged gives us a record of craters and the absence of resurfacing. It does not give us a profile of what lies beneath the floor. There could be layers of different composition, different reflectivity at different depths, and the Wunda impact, large enough to carve a 131-kilometer basin, could have reached one of them. The ejecta hypothesis is the least constrained of the four, which means it is the hardest to confirm and the hardest to rule out. It sits in the pile of possibilities not because it is particularly well supported by any positive evidence, but because the absence of detailed knowledge about Umbriel's interior structure leaves room for it. It is honest uncertainty, not special pleading. The fourth possibility involves the redistribution of volatiles, not by cold trapping in the strict sense, and not by magnetospheric processing in the way the Dwest trailing hemisphere result points to, but by some later, more local rearrangement of material on or near Umbriel's surface. Perhaps the impact that formed Wunda heated material in the crater region, and that heating drove off or reorganized volatile compounds that subsequently recondensed on the cool floor in a pattern that happens to ring the interior. Perhaps geological or tidal processes, if any remain, which seems unlikely given how geologically quiet Umbriel appears to be, have moved material in the deep past. Perhaps the geometry of how Wunda sits relative to the Sun and Uranus's magnetic field has produced a local microenvironment within the crater that concentrates material differently over time. This fourth idea is perhaps best understood as a family of ideas rather than a single well-defined hypothesis, a catch-all for the possibility that the ring formed through some local volatile behavior that does not fit neatly into the cold trap or fresh ice or unusual ejecta frameworks. It is the least specific of the four, which makes it the most difficult to work with scientifically. But it is not therefore wrong. Science maintains these possibilities not because they are equally likely, but because the evidence is insufficient to eliminate them. Four possibilities, each with something in its favour. None confirmed. There is a second bright feature on Umbriel, one that appears in the Voyager images near the terminator, the line between the lit and unlit portions of the Moon, on the central peak of another crater. It is fainter than the Wunda ring. It did not capture the imagination or the scientific attention that the Wunda ring has, partly because it is less dramatic, and partly because the Wunda ring was easier to study in the available images. But its existence is a quiet suggestion that whatever process produced the bright material in Wunda may not be entirely unique to that one crater. It hints, and hints only, nothing stronger than that there may be more brightness hiding in Umbriel's craters than the one famous ring. That the Moon that appeared, in Voyager's brief images, as almost completely dark except for one pale loop of light, may be slightly more complicated than even that simple picture, but only slightly, and maybe. The second feature is tentative, the images in that region of the Moon more difficult to read. It is worth holding on to as a possibility, as one more open loop in a question already rich with open loops, rather than as a settled observation. What none of the four hypotheses has yet resolved, what the J/S result has moved closer to resolving without actually closing, is this central question: why there? Why Wunda? Specifically, why is the bright ring in this particular 131-kilometer crater at 6 degrees south latitude, and not in some other crater? If cold trapping concentrates CO2 from the magnetospheric bombardment of the trailing hemisphere, why is the most prominent collection point this specific crater rather than others? If the Wunda impact excavated fresh ice, why is the Wunda impact the one that left visible bright material when other craters did not? If the ejecta from the impact were different in composition, what made this impactor or this subsurface layer special? None of the four ideas gives a fully satisfying answer to that narrower question of specificity. And that narrower question is, in a way, the heart of the mystery. Not only what the ring is made of, but why it is here, in Wunda, glowing on this particular dark world, in this particular shadowed crater, named for a spirit of darkness. The answer to that question is waiting. It is not waiting in any current data set. It is waiting somewhere on Umbriel itself, in the chemistry and structure and thermal history of the crater floor and what lies beneath it, patient and cold and still, 2,007 billion kilometers from the nearest human being, in a level of cold and quiet that is difficult to hold in the mind for very long. And yet there is one more way to approach that question of specificity, one more quiet mechanism to consider before the mind settles, and it begins not with the crater itself, but with a kind of cold that is almost impossible to picture from where you are lying right now. 75 Kelvin, that is the surface temperature on Umbriel, approximately, to translate it into something the body can feel, minus 198 degrees Celsius. On the Fahrenheit scale that most Americans carry around in their heads from weather reports and cooking, it is roughly minus 324 degrees. There is no analogy from ordinary life that quite reaches it. Not really, because there is nothing in ordinary life that cold. The coldest temperature ever recorded on the surface of Earth was about minus 89 degrees Celsius in Antarctica in 1983. That was the deepest natural cold the surface of our planet has ever achieved, and it was still more than 100 degrees warmer than a typical afternoon on Umbriel. The coldest spot in your household freezer, where ice cream goes hard as stone, runs at around -18 or 20 Celsius. Umbriel is almost 10 times colder than that, and that is not the cold of a polar storm or a record-breaking winter. That is just the ordinary, unremarkable, midday temperature of the surface of that world, going about its existence as it always has, for billions of years, without anything unusual happening at all. At that temperature, nearly everything freezes. Water ice, obviously, but also things that behave as gases at room temperature in your house. Carbon dioxide, the same gas that makes sparkling water fizz and that dry ice is made of. The same gas that leaves your lungs with every slow breath you take right now. At 75 Kelvin, carbon dioxide is not a gas at all. It is a rigid, crystalline solid. It does not drift through the air because there is no air, and even the faint traces of gas that might exist near Umbriel's surface at other temperatures would, at this temperature, be pressed by the cold into a frost. A fine pale deposit of frozen carbon dioxide crystals settling onto whatever cold surface they reached first. This is the cold trap mechanism, and it is worth holding in the mind for a moment, because it is the mechanism that of all the 4 hypotheses for what the bright ring in Wunda crater might be, has gathered the most new evidence in recent years. A cold trap is exactly what the name suggests. It is a place so cold that volatile molecules that would normally drift or sublimate away at warmer temperatures, are caught when they arrive and cannot leave. They freeze down onto the surface, and they stay. The trap does not need to be sealed by any physical wall. The cold itself is the enclosure. The molecule lands, gives up its energy to the surrounding material, drops its temperature to match the surroundings, and is held, immobile and crystalline, for as long as the cold endures. On Umbriel, the cold endures for an extremely long time. The seasons change slowly on a planet with a 98-degree tilt, and while some parts of the surface do eventually receive more direct sunlight as the decades and centuries of Uranian orbit proceed, the deep floors of craters near the equator can remain in shadow for durations that are difficult to express in any timescale that means something to a human life. Picture it this way. Imagine that you could stand on the dark level floor of the Wunda crater, 131 kilometers of ancient rock and ice bearing regolith stretching away in every direction around you in the absolute dark. Above you, the crater walls rise, and beyond those walls, Uranus hangs in the sky, enormous and pale. A greenish sphere lit sideways by a sun that from here looks little more than a very bright star. Brilliant and clear, but cold and small, in a way that the sun we know never looks from Earth. The light that reaches the crater floor from that small sun is already faint by the time it arrives in this part of the solar system, about 400 times weaker than the sunlight reaching your window at home. And then the crater walls cut even that diminished light, throwing the floor into deep geometric shadow for much of the time, as Umbriel slowly rotates, once every 4 days, with that sun tracing a low, cold arc across the sky. In that shadowed cold, CO2 molecules arrive. They do not arrive in a rush or a flood. They arrive the way fine dust arrives on a still surface, slowly over time, by the accumulation of small events repeated across millions of years. The question is where they come from, and this is where the newest piece of evidence, the piece from the James Webb Space Telescope, changes the conversation in a way that the 1986 Voyager data alone could never have done. For a long time, the simplest assumption was that carbon dioxide on the surfaces of moons like Umbriel might be primordial, ancient ice that had been part of the moon since its formation in the disk of material that orbited Uranus billions of years ago. The same way water ice is an old constituent of these worlds. But that assumption turns out to be harder to sustain when you look carefully at where the CO2 is concentrated. And the James Webb Space Telescope, using its NIRSPEC instrument to analyze the near-infrared light reflected from the surfaces of the inner Uranian moons, found something that changes the picture. Researchers, including Richard Cartwright and colleagues, working with the Webb telescope's remarkable spectroscopic sensitivity, detected the chemical signature of carbon dioxide ice on Umbriel and other inner moons. And the concentration was not uniform. It was not spread evenly across the surface the way ancient primordial ice would tend to be, mixed in with everything else from the beginning. The CO2 signal was strongest on the trailing hemispheres of the inner moons, on Ariel and on Umbriel, concentrated specifically on the sides of the moon that face backward as they move through their orbits. This matters enormously, and it matters in a way that points to something active and ongoing, rather than ancient and passive. The trailing hemisphere of a tidally locked moon is the side that faces into the direction the moon has come from, the rear face, as it moves along its path. In a world with a magnetosphere, a bubble of charged particles and magnetic field lines surrounding it, the trailing hemisphere is the side that gets preferentially bombarded by charged particles swept up in the planet's magnetic environment. Uranus has a magnetosphere, a strange and lopsided one, tilted at a large angle relative to the planet's axis, in a way that makes it unusual even among the unusual things in the outer solar system. The charged particles trapped in that magnetosphere circulate through it and strike the trailing faces of the inner moons more than the leading faces, simply because of the geometry of how the moons move through that environment. When those charged particles strike a surface, they do not just warm it or erode it in the way you might imagine a physical impact doing. They break chemical bonds, they knock atoms and molecules apart, and allow them to recombine in new configurations. This process is called radiolysis, radiation-driven chemistry, and it is capable of manufacturing molecules that were not originally present by splitting existing compounds and reassembling the pieces differently. If the surface of Umbriel contains organic rich or carbon-bearing material, and there is reason to believe it does based on its dark color and composition, and if it also contains water ice in some form, then the charged particles from Uranus's magnetosphere bombarding the trailing hemisphere can break these apart and create carbon dioxide in place on the surface as a product of ongoing radiation chemistry, not ancient CO2 from formation. New CO2, manufactured now, or at least manufactured on a continuous and ongoing geological timescale, a slow, steady production process that has been running for as long as Umbriel has orbited inside Uranus's magnetosphere. The trailing hemisphere concentration found by Cartwright and colleagues is the fingerprint of this process. Ancient primordial CO2, mixed in from the beginning, would not preferentially concentrate on one side of the moon. The fact that it does concentrate on the trailing side is the signature of a source that is coming from outside, from the magnetospheric bombardment, rather than from inside the moon. This does not prove that the bright ring in Wunda crater is made of CO2 frost. The GES data is a disk average detection. It sees the hemisphere, not the individual crater. It cannot zoom into the floor of a 131-kilometer crater and tell you what sits there specifically. But it tells you that CO2 is being produced on Umbriel's trailing hemisphere right now. or at least on a continuous modern timescale, and Wunda crater is near the equator, at about 6 degrees south latitude, which places it in a position where it could accumulate material from the trailing hemisphere's CO2 production. The cold trap mechanism then takes over. CO2 molecules, once produced and briefly mobile as gas or frost, migrate across the surface and preferentially settle onto the coldest available spots, which on a slowly rotating moon at equatorial latitudes can be the shadowed, geometrically sheltered floors of deep craters. This is a plausible chain. Each link in it is real and documented. The magnetosphere bombards the trailing side. The bombardment manufactures CO2 by radiolysis. The CO2, being volatile at somewhat higher temperatures, can migrate slightly across the surface. The shadowed crater floor is colder than the surrounding terrain. The cold trap concentrates the CO2 frost over long periods. The result, after millions of years, might be a visible, bright, pale ring of accumulated frost on the floor of Wunda crater, the highest albedo feature on the entire moon. Each step of that chain is supported by something real, by the known physics of radiolysis, by the GS detection of CO2, by the cold trap thermodynamics, by the geometry of the crater. And yet it remains not proven. Because the chain has gaps, and the most important gap is the one already named, we have never looked at Wunda crater's floor closely enough to confirm the composition of the ring. We have one set of images from Voyager 2 taken in January 1986 at modest resolution with the crater near the limb of the moon, seen nearly edge-on, catching the ring as a bright annulus silhouetted against the dark. Those images tell us the ring is there. They tell us it is brighter than its surroundings. They do not tell us, and cannot tell us, what it is made of. The JWEST data tells us CO2 is present on the trailing hemisphere of Umbriel, but it cannot resolve a single crater. The connection between the two observations, the JWEST CO2 and the Voyager bright ring, is a compelling inference, and compelling inferences are what science is built from when it cannot yet observe directly. But it is still an inference, not a measurement of the ring itself. And so the honest answer, the answer that the science actually supports, is the cold trap CO2 frost hypothesis is the most strengthened interpretation right now, bolstered by recent evidence, coherent with known mechanisms, and consistent with what little Voyager showed us. But it is not confirmed. The ring's composition is still unknown. The case is more persuasive than it was before the Webb telescope turned its instruments toward Uranus's moons, but it is not closed. There is something almost comforting in that, if you let yourself feel it. The universe is not withholding the answer out of cruelty. It is simply that the tools we have so far, one flyby in 1986 and a telescope that can see the whole hemisphere but not one specific crater, are not yet fine enough to reach the answer. It is there, on the floor of Wunda, solid and frozen and patient. It is not hiding. We simply have not yet built the instrument that can go look at it properly. And there is one more thing to hold before the question is left to rest. A hint, a small and tentative one, that the bright ring in Wunda may not be entirely alone on Umbriel. In the Voyager images, there is a second feature, fainter, less dramatic but notable, a bright spot on what appears to be the central peak of another crater, near the terminator, the boundary between the lit and unlit portions of the moon. Central peaks are common in large craters. They form when the rock beneath the impact site rebounds upward after the collision, pushing a mound of material up through the center of the crater floor, the way the surface of water bounces upward after a drop falls into it and then briefly rises before settling back down. The material in a central peak is often drawn from deeper layers, brought up from below the older, weathered surface into the light. If there are brighter or compositionally different layers beneath Umbriel's dark exterior, a central peak might expose them. A small bright protrusion of fresher or ice-richer material pushed up into a world of otherwise uniform shadow. This second bright feature is far less prominent than the Wunda ring. It is easy to overlook in the images. But it is there, and it suggests tentatively that Wunda may not be the only crater on Umbriel to show unusual brightness. If the cold trap frost hypothesis is correct, perhaps other craters elsewhere on the Moon, on the 60% of its surface that Voyager never saw, on the whole northern hemisphere still waiting in the dark, bear similar frost deposits, similar pale rings or bright flaws, accumulated over billions of years of bombardment and cold trapping that we cannot yet observe. Perhaps Wunda is not exceptional. Perhaps it simply had the fortune, if fortune is the right word, of being placed where the one spacecraft that has ever passed this world could see it, caught near the equator, near the limb, lit just well enough that the ring stood out against the surrounding dark. Perhaps the northern hemisphere of Umbriel, never photographed, carries a dozen Wundas, or none. It is impossible to know. That is perhaps the deepest layer of the mystery, and the one that rewards sitting with rather than trying immediately to resolve. Umbriel's secret is kept not only by its chemistry and its cold and its distance, but by the fact that more than half of it has never been seen by any human-made instrument. We are reasoning about a world we have met only in passing, briefly, from a distance, on a winter day nearly 40 years ago. The ring is the most prominent feature of the most carefully studied portion of that world. What the rest of it looks like, whether there are brighter places, whether there are dark spirits and cold halos in other craters with other names, is unknown in a way that is not mysterious in the conspiracy sense, not hidden, not lost, simply unseen. The light from Umbriel that reaches telescopes on Earth is too faint and too blurred by distance to resolve individual craters. Nothing since Voyager has come close enough to try. And so the question waits. There is a mission being planned. The idea has been discussed, debated, prioritized, and in 2023, the answer from the community of planetary scientists came back clearly. A Uranus orbiter and probe was ranked the top priority for the next large-scale NASA flagship mission. The top priority. Not Mars, not an asteroid, not a return to a known world. Uranus, the tilted, cold, understudied ice giant with its strange magnetic field and its suite of dark, ancient cryptic moons. The decadal survey that sets the priorities for NASA's largest scientific missions placed this mission at the head of the list, which is not a guarantee that it will be built on any particular schedule, because flagship missions take years to plan, fund, design, and launch, and then years more to travel to their destinations. But it means the scientific community has looked at what remains unknown in the solar system and decided that Uranus and its moons represent one of the deepest gaps in our understanding. And among those moons, Umbriel, dark, ancient, geologically quiet, wearing its one unexplained ring, is one of the objects waiting to be understood. If and when a spacecraft settles into orbit around Uranus, rather than flying past it in a matter of hours, the way Voyager 2 did in 1986, it will have time. It will be able to map the full surface of Umbriel, including the northern hemisphere that has never been imaged. It will be able to look directly at the floor of Wunda crater, not edge on from the limb, but straight down, at real resolution. with instruments far more capable than anything Voyager carried. It will be able to take spectra of the bright ring, measuring the wavelengths of light it reflects, and comparing them against the known signatures of CO2 frost and water ice and other materials, and from those measurements it will be possible to say, at last, what the ring is made of. That is not science fiction. That is the next step, when the hardware is ready and the journey has been made. But that journey has not been made yet. The hardware does not yet exist. The mission is an intention, a plan, a high-ranking entry on a list of priorities, and until it launches and travels the billions of kilometers to Uranus and enters orbit and points its cameras at Umbriel, the ring in Wunda crater will remain what it has been since January 1986, the one bright thing on the darkest large moon in the solar system, seen once, understood incompletely. Composed of something that is probably CO2 frost and maybe fresh ice, and might be ejector or redistributed volatiles or some combination that the data cannot yet separate, and positioned in a specific crater for reasons that none of the four hypotheses has fully explained. That incompleteness is real. It is not a hedge or a rhetorical device or a way of keeping the video going a little longer. It is the actual state of knowledge. The scientists who work on the Uranian moons, who study the Dwest spectra and model the cold trap dynamics and read the old Voyager data, looking for things previously missed, do not know what the ring is made of. They have ideas, and some of those ideas are better supported than others, and the CO2 frost hypothesis has gained ground. But not one of them would tell you the question is answered. The ring is a genuinely open case, and it has been open since the day the Voyager images came back from the machine, and it will remain open until a better instrument goes to look. And there is something in that openness that is worth staying with as the night deepens. Think about what the ring represents in a larger sense. Not the specific chemistry, not the albedo measurements, not the radiolysis process or the cold trap thermodynamics. All of that is the mechanism, and the mechanism is beautiful and worth understanding on its own terms. But underneath the mechanism there is something simpler, something the mind can rest on more easily than the mathematics of magnetospheric charged particle bombardment. There is a world, roughly the size of the distance from Chicago to Denver in diameter, made of roughly half rock and half ancient ice, orbiting a planet 7 billion kilometers from the nearest human being, in a cold that makes the coldest place on Earth feel warm, covered almost uniformly in a dark material so absorptive that it takes in 90% of what little sunlight reaches it and returns almost none. A world that formed when the solar system was young, that has been struck by countless objects over billions of years and carries the craters of those impacts like a record of everything that has ever found it. A world that has no volcanoes, no active geology, no internal heat, leaking out to reshape its face, no atmosphere to weather anything, no seasons in any sense that changes its surface. Just cold and dark, and the slow accumulation of impacts across a timescale that contains every human civilization that has ever existed many millions of times over. And on that world, in one crater near its equator, there is a ring of something brighter than the rest. One ring, not dozens, not a network of bright features scattered across the surface. One, in one crater, named Wunda, named for a dark spirit in Australian Aboriginal tradition, as all the craters on this moon are named for dark spirits and shadowed beings from the mythologies of the world. The whole naming system of this moon is built from shadow. The moon itself carries the name of a shadow sprite from a poem written in 1712, a dusky, melancholy gnome called Umbriel, and its craters bear names drawn from the dark corners of every tradition that humans have used to give shape to the unknown. And in one of those craters, one of those dark named places on this shadow-named moon, there is a pale ring. That is the image to hold. Not the chemistry, not the spacecraft trajectory, not the temperature in Kelvin. Just the image, a ring of pale material, the brightest thing on a nearly black world, sitting in the cold on the floor of a crater named for a dark spirit, on a moon named for shadow, orbiting a planet so far away that the sun looks like a bright star from there, and so cold that carbon dioxide freezes solid on the ground the way ice freezes solid in your freezer, and so dark that it absorbs almost everything and gives back almost nothing. And in all of that darkness, this one thing glowing softly. Not brightly. There is no brilliance here, no blazing light. The ring is bright only relative to the profound darkness surrounding it, the way a single candle in a very dark room seems to fill a space that would otherwise be lost entirely. Relative to what is around it, the ring glows. On its own terms, it is just pale material on a cold floor, reflecting back a little more of the faint sunlight that falls on it than the rest of the surface manages to return. But that is enough. It is enough to have been seen from 81,500 kilometers away by a spacecraft passing at high speed, with cameras designed for the 1970s and 1980s. In the few hours that Voyager 2 was close enough to image the surface of Umbriel at all. It was enough to stand out against the dark grey of everything around it. It is enough, nearly 40 years later, for the James Webb Space Telescope to detect the chemical signature of carbon dioxide on the trailing hemisphere where Wunda sits, and to begin building a case, incomplete but suggestive, for what the ring might be. It is enough to make it the most noted feature of a moon that is itself one of the most ignored large moons in the solar system, overshadowed in the popular imagination by the moons of Jupiter and Saturn, passed by in a single afternoon in 1986 and not visited since. Something is there. We do not know exactly what it is. We know where it is, and how bright it is relative to its surroundings, and roughly how large the crater that contains it is, and something about the chemistry of the hemisphere it sits on, and something about the mechanism that might have put it there. That is a great deal more than nothing, and a great deal less than a full answer. It is the position science typically occupies with the universe, knowing more than it did, less than it needs to, working with what the instruments have provided and waiting for better instruments to provide more. Wunda Crater is quiet tonight, which is to say it is quiet every night and every day in the way that all things at that distance and that temperature are quiet, in a silence that is not like the silence of a room where the noise has stopped, but more like the silence of something that has never made noise at all, that has been this still and this cold for so long that the concept of noise or warmth does not apply. A silence so complete it has more in common with a state of being than an absence of sound. The ring on its floor is undisturbed. The charged particles from Uranus's magnetosphere are still arriving on the trailing side of the moon, still breaking bonds, still manufacturing molecules of CO2 in the slow ongoing chemistry of radiation, and some of what is manufactured is probably still finding its way, in time, to cold and shadowed places and freezing there, adding to whatever is already on the crater floor. One molecule at a time, over timescales that contain the entire history of the human species, the way a day contains a single heartbeat. Nothing is rushing. Nothing is waiting for an answer. The crater does not know it is being thought about, or that it was photographed 40 years ago by a spacecraft traveling through on its way out of the solar system, or that a telescope in orbit around Earth has measured the chemistry of the hemisphere it sits on, or that the people who study these things have placed it on a list of things they want to understand better when the means become available. The crater simply exists. The ring exists. The cold and the dark and the faint recurring light of Uranus in the sky above Umbriel exist. All of it without urgency, without impatience, without the anxiety of an unanswered question. Because the question is a human thing, and out there beyond the question and the asker, things simply are what they are, calmly and completely. There is a certain comfort in that, on a night when the mind wants to be still and the body wants to rest. The universe contains mysteries of this kind, precise, real, located in specific places that can be named and measured, surrounded by evidence that is accumulating slowly and honestly, moving toward an answer without yet arriving. The bright ring in Wunda crater is not a crisis. It is not alarming. It is simply one of the things we do not yet fully understand. Sitting out there at an extreme distance in an extreme cold, holding its composition to itself for now, waiting for the moment when a better instrument arrives to look at it properly. That moment will come. Maybe in a decade, maybe in 2, maybe in a time when people not yet born will be old enough to work on the instruments that go there. The Uranus orbiter and probe, when it is built and launched and arrives, will carry spectrometers capable of resolving individual craters, and one of the first things those spectrometers will likely be directed toward is the floor of Wunda. On that day, probably sometime in the second half of this century, the question will have an answer. The ring will be named CO2 frost, or exposed water ice, or some mixture of both, or something that the current hypotheses have not yet articulated. And the answer, whatever it is, will be another piece of the long, patient accumulation of knowledge about the places in this solar system we share, all of it proceeding in its own time. Without hurry, without drama. Tonight, though, the answer is not yet here. Tonight, what there is the image of the ring itself, pale and quiet, on the floor of a dark crater on the darkest large moon of Uranus, 2.7 billion kilometers away, in a cold that passes all ordinary description, glowing just enough against its surroundings to have been noticed, named, studied, and wondered about by human beings who looked at the images from a 40-year-old spacecraft and asked, "What is that? What is that ring? Why is it there?" Those are questions worth having asked. They are questions worth continuing to ask, even when the answer is not yet available. They are part of what it means to look at the universe with attention and curiosity and the willingness to sit with something unresolved, to not need the answer tonight, to be content to rest in the vicinity of a mystery that is genuine and deep and not going anywhere. Let it rest now, that question. Let Wunda crater rest in its cold and its dark. Let the ring sit there as it has sat for however long it has been accumulating, patient beyond any patience a human life can demonstrate. Let the charged particles from Uranus's magnetosphere continue their slow work on the trailing hemisphere, manufacturing their CO2 in the dark chemistry of radiation, adding perhaps a molecule or two to whatever is already on the crater floor, unhurried, unobserved for now, doing what physics does when nothing is watching. The ring is there. It was there before you heard of it, and it will be there after this night passes into morning, and it will be there when the mission that finally goes to photograph it up close is still a line of text in a planning document. And it will be there when that mission launches. And it will be there when the spacecraft arrives. It does not need to be solved tonight to be worth holding in the mind tonight. It is enough to know it exists. One point of light in overwhelming darkness. If you are listening to this from somewhere in the world where the night has settled in and the day's concerns have finally begun to loosen their hold, I hope this slow journey out to Umbriel and back has given your mind one calm place to rest. The mystery is real. The ring is real. The cold and the dark and the one pale halo are all real. Out there at the edge of the solar system's more familiar territories, on a moon we have visited exactly once, briefly and imperfectly, and that is waiting with something like patience. Though, of course, patience is a human quality, and Umbriel has none of that, has nothing at all, only chemistry and cold, and that one luminous feature it cannot explain, and neither yet can we. If you feel moved to share where in the world you are listening from tonight, I would genuinely like to know. The comments are there, and I read them. And there are more slow stories here, of the same kind and at the same careful pace, waiting for whenever you want them. You have done enough for one night. Put down whatever remains of the day. Let the darkness be comfortable. Let the quiet in your room be its own kind of cold and still. Let Wunda crater hold the unanswered question for you. Out there, in the dark too, 7 billion kilometers away, until some future morning when the answer is finally returned. Good night from up here in orbit. I'll keep watch while you drift.